looking at a vacuum, okay? I'm trying to read up here. We're going to look at a vacuum, and so what we have is, I'm going to take air out from underneath this right here, and even though I like cartoons, cartoons are terrible sometimes. As a matter of fact, if you're a cartoonist, there's even a rule. When does a cartoon character, when they go off a cliff, when do they start falling? When they run off the cliff, they don't fall. When do they start falling? Only when they what? Only when they notice it, and then they fall. Okay, that's not physics. And so another thing they do in cartoons is this. When they put you in some place, like they say space or they say a vacuum, if they put you in a vacuum, they start playing twinkly music and things start floating. Well, there's a problem with that, see that? Just because you have a vacuum, I'm going to take the air out of this, see this? Does that mean the earth is not pulling on things anymore? They still have weight, don't they? They're not going to become weightless because you have no air. Now, by the way, if I take the air out of this, the air pressure would crush it. Except the company knew that, and what did they do? They made the glass out. That's really thick, isn't it? And what else did they do? What's that? An arch, like a dome? Okay, so they thought about this, didn't they? So the first thing I like to do is, here it is. I'm going to ask you a question. You think, that's a dumb question. Why is this balloon this big? Why is it this big? What do you think? Ryan, you haven't said anything today. Why is this balloon this big? That's right. I only put a little bit of air in it, didn't I? Isn't that it? Isn't that it? Is that right? Is that the only thing? Is there anything else that might determine how big that balloon's going to be? What do you think?
There's 1 atmospheric unit of pressure pushing on every side of it.
Is there somebody pushing this way? Okay. And is there anything else? Is there any other thing that might determine the size of that balloon? What?
Temperature.
Temperature, right? Right. That's true. That's true. If it was warmer, it would be a little bigger. Yes?
Pressure inside the balloon pushing back on the outside.
What's that? What's doing that? The rubber. That's right. It's elastic, isn't it? This balloon wants to go back to its original size, isn't it? So there are 3 things we're looking at, isn't it? Let me ask you another question before I use the vacuum. Which one's greater, the air pressure in that balloon or out here? Or are they the same? What do you think? How do people think the air pressure in here is higher than it is out here? Oh, nobody? How do people think out here is higher than in here? How do people think they're the same? Oh, that's good. I love that. Let me ask you a question though. If I took a little tiny needle, and I'm just gonna put a hole in it. I'm not gonna pop it. I'm just gonna put a hole in it. What happens?
Air comes out.
Why? Why would air come out?
The pressure from the elastic.
Because what now?
The pressure from the
Pressure
elastic.
inside here is actually greater than it is out here. See that? You might say, whoa, wait. If the pressure in here is greater than out here, then the balloon would keep getting bigger and bigger. You forgot about something. What's that? What's that? What's the elastic doing? What's the rubber doing? It's preventing it from getting bigger and bigger and bigger, isn't it? All right, so let's try it. So what I'm going to do is, I'm going to take all the air out from around the balloon, and then we'll see what happens to the balloon. Oops. I'm good skill there. So if you thought it was only because I only put a little bit of air in there, that's not the whole story, because I didn't put any more air in, did I? And yet the balloon keeps getting bigger and bigger. I'm just removing the air pressure on the outside. Now, what do you think's going to happen when I put it back in? There you go. See that? All right, there's that.